There's an engine so catastrophically bad that it destroyed Ford's reputation for reliability, cost the company $3 billion in warranty claims, and left hundreds of thousands of owners stranded on the side of the road. It's called the 3.8-liter Essex V6, and between 1996 and 2008, Ford installed this ticking time bomb in over 8 million vehicles, knowing the entire time that it was fundamentally flawed. The engine that powered the Ford Windstar, Mercury Sable, and countless other Ford products had a fatal design flaw that caused catastrophic failure between 60,000 and 120,000 miles. Head gaskets that were guaranteed to fail. Intake manifolds made from plastic that cracked and dumped coolant into the engine. Timing chain guides that disintegrated and let the engine destroy itself from the inside. And Ford knew about every single problem because the failures were so consistent they could predict when your engine would die based on the day it rolled off the assembly line. If you owned a Ford with a 3.8-liter V6 between 1996 and 2008, you didn't have a car. You had an expensive countdown timer to engine failure. This is why the Essex V6 is the worst engine Ford ever built, how it destroyed thousands of vehicles, and why Ford kept installing it for 12 years despite knowing it was defective. The 3.8-liter Essex V6 started production in 1982 and ran until 2008, 26 years of production. Most engines improve over time as engineers fix problems and refine the design. The Essex V6 got worse. Ford made cost-cutting changes in the mid-1990s that transformed an acceptable engine into a reliability disaster. The original Essex design from 1982 through 1995 was fine, not impressive, but functional. It had a cast-iron intake manifold, traditional gasket materials, and decent timing chain components. Then Ford's accountants got involved. Plastic is cheaper than cast iron and easier to manufacture. The problem is that plastic expands and contracts with temperature changes differently than the aluminum cylinder heads it bolts to. Over time, the thermal cycling causes stress cracks. Those cracks let coolant leak into the intake runners and eventually into the cylinders. But here's where it gets catastrophic. When coolant leaks into the cylinders, it mixes with engine oil. This creates a sludgy mixture that can't lubricate properly. Your engine runs low on coolant, overheats, and simultaneously loses lubrication. The result is seized pistons, scored cylinder walls, and destroyed bearings. A cracked intake manifold doesn't just need replacement, it kills the entire engine. Ford knew about this problem by 1999. Internal documents from class action lawsuits show that Ford engineers flagged the intake manifold cracking issue and recommended returning to metal components. Management rejected the recommendation because retooling would cost $50 million. So they kept building engines with plastic manifolds that they knew would fail, calculating that warranty costs would be less than fixing the design. They were wrong. The warranty costs exceeded $3 billion. But by then, millions of defective engines were already in customer vehicles. The intake manifold problem was bad enough on its own. But the Essex V6 had a second fatal flaw that made everything worse. The head gaskets were guaranteed to fail, and when they did, the engine was finished. Head gaskets seal the connection between the cylinder head and the engine block. They have to withstand extreme pressure, temperatures up to 2,000 degrees Fahrenheit, and constant thermal cycling. Most modern head gaskets last 200,000 miles or more. The Essex V6 head gaskets failed between 60,000 and 120,000 miles, with such consistency that mechanics could predict failure based on mileage alone. The problem was the gasket material and the bolt torque specifications. Ford used a composite head gasket that couldn't handle the thermal stress of the engine's operating conditions. The gaskets would compress and deteriorate, eventually allowing combustion gases to escape and coolant to leak between cylinders. But the real issue was Ford's assembly process. The cylinder head bolts were supposed to be torqued to specific values in a specific sequence to evenly distribute clamping force. Assembly line workers were given inadequate time to properly torque the bolts. Quality control data from the Romeo engine plant in Michigan shows that up to 30% of engines left the factory with improperly torqued head bolts. Those engines were doomed from day one. You get coolant mixing with oil again, white smoke from the exhaust, rapid coolant loss, oil that looks like chocolate milk, and most critically, cylinder head warping from overheating. Even if you replace the head gasket immediately, the cylinder heads are often warped beyond the service limit and need to be machined or replaced. A head gasket job that should cost $800 turns into a $3,000 repair because the heads are damaged. Thousands of owners experience this. They'd buy a used Ford Taurus or Windstar with 80,000 miles, thinking they were getting a reliable family vehicle. The head gasket would fail, and they'd be facing a repair bill that exceeded the vehicle's value. Most people just junked the cars and swore never to buy Ford again. If the plastic intake manifold and defective head gaskets weren't enough, the Essex V6 had a third failure mode that could destroy the engine in minutes. The timing chain guides were made from plastic that deteriorated with age and mileage, and when they failed, the timing chain would jump or break, causing catastrophic internal damage. The timing chain is what synchronizes the crankshaft and camshaft rotation. If the timing chain jumps even one tooth, the valves and pistons are no longer synchronized. Valves open at the wrong time. Bent valves, damaged pistons, destroyed cylinder heads. Engine scrap. Most engines use metal timing chain guides or high-quality polymer guides that last the life of the engine. Ford used cheap plastic guides that became brittle after 100,000 miles. Heat, oil contamination, and age caused the plastic to crack and break apart. Pieces of broken guide would fall into the oil pan. The timing chain would lose its guide track and start to wander. Eventually, it would jump timing or break entirely. The worst part about timing chain failure is that it happens without warning. No check engine light, no unusual noises, no gradual degradation. One moment you're driving normally, the next moment the engine makes a horrific grinding noise and dies. You coast to the shoulder and your engine is destroyed. Total loss. Ford issued multiple technical service bulletins about timing chain noise and rattle, but never recalled the engines or offered extended warranty coverage for timing chain failures. Owners were left with $4,000 to $6,000 engine replacement bills for a problem that was entirely due to Ford's use of inferior materials to save $5 per engine in manufacturing costs. Even if you were lucky enough to avoid intake manifold failure, head gasket failure, and timing chain failure, the Essex V6 had one more way to destroy itself. Excessive oil consumption that Ford denied was a problem until lawsuits forced them to acknowledge it. Starting around 2000, owners began reporting that their Essex engines were consuming a quart of oil every 500 to 1,000 miles. This is not normal. A healthy engine might consume a quart every 3,000 to 5,000 miles. The Essex was burning oil at 10 times the normal rate. The cause was piston ring wear and valve guide seal deterioration. Ford's piston ring design for the Essex used lower tension rings to reduce friction and improve fuel economy. Lower tension means less cylinder sealing. Combustion gases blew past them, causing oil to burn in the combustion chamber. The valve guide seals also failed prematurely, allowing oil to leak down the valve stems into the cylinders. Ford's official position was that 1 quart per 1,000 miles was within normal specifications. This is absurd. No other manufacturer considers that acceptable. But Ford maintained this position because acknowledging excessive oil consumption would trigger warranty claims on hundreds of thousands of engines. The problem with burning oil isn't just the inconvenience and cost of constantly adding oil. It's that most owners don't check their oil frequently enough. They assume their engine isn't consuming oil at alarming rates because no car should do that. So they drive with low oil levels. Low oil means inadequate lubrication. Inadequate lubrication means accelerated wear on bearings, camshafts, and cylinder walls. Eventually, catastrophic failure. Countless Essex engines seized due to oil starvation caused by consumption that Ford refused to acknowledge as defective. Owners would bring their car in for routine maintenance at 3,000 miles. Mechanics would find the oil level barely reading on the dipstick, and Ford would blame the owner for not checking oil between changes. Even though the engine was designed to fail this way, Ford installed the defective 3.8-liter Essex V6 in some of their highest volume, most important vehicles. This wasn't a niche engine in a low-production specialty car. This was the base engine in family vehicles that millions of Americans depended on. Ford Windstar minivans from 1995 to 2003. The Windstar was Ford's primary competitor to the Dodge Caravan and Honda Odyssey. It was supposed to be a reliable family hauler. Instead, it became known as one of the least reliable minivans ever built, primarily because of the Essex engine. Consumer Reports gave it their lowest reliability rating. J.D. Power ranked it at the bottom of minivans for dependability. Resale values collapsed. You could buy a 5-year-old Windstar for $3,000 because everyone knew the engine was going to fail. Ford Taurus and Mercury Sable from 1996 to 2007. Rental cars, family sedans, high-mileage use cases where reliability is critical. The Essex engine turned these into money pits. Police departments and taxi companies that had been loyal Ford customers switched to Toyota and Honda because they couldn't afford the downtime and repair costs of the Essex engines failing. Ford Mustang base models from 2001 to 2004. Even the iconic Mustang wasn't spared. The V6 Mustang was supposed to be the affordable entry point to Mustang ownership. Instead, it became the model that enthusiasts mocked for having an engine that couldn't be trusted to last 100,000 miles. Mustang forums are filled with stories of blown head gaskets, cracked intake manifolds, and timing chain failures in Essex-powered base models. Ford's reputation for reliability was destroyed by this engine. In the 1990s, Ford was competitive with Honda and Toyota in consumer reliability surveys. By 2005, after a decade of Essex failures, Ford had plummeted to near the bottom of every reliability ranking. The company's market share collapsed. Resale values on Ford products were the worst in the industry. Customer loyalty evaporated, all because accountants decided to save $50 million by using plastic intake manifolds instead of metal. By 2001, the failures were so widespread that class action lawsuits were filed in multiple states. Owners demanded reimbursement for repair costs, extended warranty coverage, and compensation for diminished resale values. The lawsuits alleged that Ford knew about the design defects and continued selling vehicles anyway, constituting fraud and breach of warranty. Internal Ford documents revealed during discovery showed that engineers had warned management about the intake manifold cracking issue as early as 1999. They recommended switching back to metal manifolds or using a different plastic formulation. Management rejected both options due to cost. They calculated that settling future lawsuits would be cheaper than fixing the design. This is the same calculation Ford made with the Pinto fuel tank in the 1970s. Compare the cost of fixing the problem to the cost of lawsuits from people dying. If lawsuits are cheaper, don't fix it. The Essex V6 didn't kill people like the Pinto did, but the corporate mentality was identical. Ford eventually settled the class action lawsuits by extending warranty coverage for intake manifold failures to 7 years or 100,000 miles on certain model years. This didn't cover all affected vehicles. It didn't cover head gasket failures or timing chain failures. And it didn't reimburse owners who had already paid for repairs out of pocket before the settlement. The total cost to Ford exceeded $3 billion in warranty claims, lawsuit settlements, and lost sales due to reputation damage. Compare that to the $50 million cost of redesigning the intake manifold. Ford spent 60 times more money managing the disaster than it would have cost to prevent it. The most insane part of this story is that Ford kept installing the Essex VL6 in vehicles until 2008, 12 years after the design changes that made it defective. 6 years after the lawsuits started, even as warranty costs spiraled and customer satisfaction ratings collapsed, Ford continued production. The reason is tooling costs and production capacity. Designing a new engine takes 5 to 7 years and costs $500 million to $1 billion. Building new production facilities takes years and hundreds of millions more. Ford's Romeo engine plant was set up to build the Essex V6. Switching to a different engine meant retooling the entire plant. Ford's management decided it was cheaper to keep building a defective engine and paying warranty claims than to invest in a replacement. This is bean counter logic at its most destructive. Save money in the short term while destroying long-term brand value and customer trust. Ford finally replaced the Essex with the Duratec 3.5-liter V6 in 2008. The Duratec is a good engine. Reliable, powerful, efficient. It's what the Essex should have been. But by then, the damage was done. An entire generation of customers had been burned by Ford's willingness to sell them vehicles with engines that were designed to fail. The Essex V6 disaster reveals everything wrong with how American automakers operated in the 1990s and 2000s. Engineers designed good products. Accountants destroy them to save pennies. Management prioritizes quarterly earnings over long-term reputation. Customers pay the price. Ford had the engineering knowledge to build reliable engines. The Duratec proves it. The modular V8, some of the same era, were solid. Ford knew how to make good engines. They chose not to because using inferior materials and cutting quality control saved money in the short term. The cost of that decision was catastrophic. $3 billion in warranty costs. Immeasurable damage to brand reputation, lost market share to Japanese competitors who built engines that lasted 300,000 miles, while Ford's couldn't make it past 100,000. Millions of customers who will never buy Ford again because the company sold them a defective product and then blamed them when it failed. The Essex V6 isn't just the worst engine Ford ever built. It's a case study in how short-term cost-cutting destroys long-term business success. Ford saved $50 million in 1996. They spent billions trying to manage the consequences. And they lost the trust of an entire generation of buyers who learned that Ford would rather save $5 per engine than build something that lasts. If you owned a vehicle with the 3.8-liter Essex V6 and it left you stranded, you weren't unlucky. You were a victim of corporate decisions that prioritize profit over reliability. And if you're shopping for a used Ford from that era, now you know why those Windstars and Tauruses are so cheap. They're cheap because everyone knows the engine is a ticking time bomb that Ford installed knowing it would fail. The worst engine Ford ever built wasn't a complicated engineering failure. It was a simple business decision that put dollars ahead of durability. And 8 million customers paid the price.